All right, welcome. Today we're going to talk about some other special quadrilaterals that are not parallelograms. So we're going to talk about trapezoids and kites. And we are going to use the properties of trapezoids and the trapezoid midsegment theorem to find distances. And students will also be able to use and apply the properties of kites. Right? Little meme for your enjoyment today. There you go. Haha, Miss Schwartz, you're so funny. I know. All right. Anyway, what is a trapezoid? A trapezoid is a quadrilateral with exactly one pair of parallel sides. So if I had to pick a key word in this sentence, it is this one. Well, probably parallel is important too, but where a parallelogram has two pairs of parallel sides, a trapezoid only has one pair of parallel sides. And these parallel sides are actually called the bases. So if you look at your picture over here in red, we have a base here and we have a base here. And we know these are parallel because they have the cool little parallel triangles on them. All right, so we also got other parts of a trapezoid. We have the base angles, we have the legs, and we're going to determine if our triangle is isosceles. So the parts of a trapezoid, the base angles. There are two pairs of base angles in a trapezoid, and they're the two consecutive angles whose common side is a base. So if I look at this particular picture, here I have a pair of base angles, and then down here I have a second pair of base angles. The purple dot and a blue dot do not make a pair of base angles because those they're not adjacent to the same base. So down at the bottom here, the purple ones touch the base here and touch the base here, and the blue dot angles touch your base up here and touch your base up here. All right, the legs are the non-parallel sides of a trapezoid. So if you look over here on the left, you have a leg, and over here on the right, you have a leg, and they are not parallel. So they're the non-parallel sides of the trapezoid. All right, in an isosceles trapezoid, if the trapezoid was isosceles, the two legs would have to be congruent. So if you see those two legs and you see those congruent signs, or they have the same length, then a trapezoid becomes isosceles. All right, so show trapezoid ABC, or show quadrilateral ABCD is a trapezoid and determine if it is isosceles. So we kind of have two key questions here. What makes a quadrilateral a trapezoid? Well, we have to have one pair of parallel sides. So looking at this trapezoid, it's pretty obvious to me that BA and CD are not parallel. So I am going to come in and I'm going to find the slope of BC. And I'm going to find the slope of AD, and I'm going to determine if those two lines have the same slope. So I know how you know how to find slope, so take a minute and find slope however you choose to do it. I will show all my work. That way, if you're lost, you can follow along. So y minus y over x minus x. And then I'm going to come down here to segment AD, -1 minus a -3, all over -2 minus 4. So this becomes 2 over -6, which is -1 over 3. All right, I have two lines with the same slopes, so I can legally come over here on my picture, and I can legally mark now that BC is parallel to AD. So that, by definition, makes this quadrilateral a trapezoid. Now, is a trapezoid isosceles? Well, now I need to find the length of AB, and I need to find the length of CD. So I'm going to do this a little bit different than I did the other day. This is a pretty good picture, so I can actually go up and over. So if I count squares, 1, 2, 3, 4, the length of this side is 4, and the length of this side is 2. And if I go from D to C, I'm going 1, 2, 3, 4, 5 up, and I'm going 1 over. So I can find the length of, or the distance of AB, and that is going to be 4 squared plus 2 squared, and this is the Pythagorean theorem / distance formula. I'm not going to simplify the square root of 20 because if I don't simplify my radicals, I can just compare the radicals as they are without simplifying them. So for CD, I have a side that's 5 and I have a side that's 1. So 5 squared plus 1 squared is going to give me 26. So these are not equal. So they are not equal, so the trapezoid is not going to be isosceles. So if they were equal, then that would tell me that my trapezoid is isosceles. But the legs are not congruent, do not have the same measure, so there we go. It's just a trapezoid. Boring. All right, so if a trapezoid is isosceles, then we know that the base angles are going to be congruent. We also know that if a trapezoid has a pair of congruent base angles, then it is isosceles. And we also know a trapezoid is isosceles if and only if its diagonals are congruent. So if you have a trapezoid with congruent diagonals, then it's isosceles. Or if it's isosceles, we can go on and say the diagonals are congruent. Alright, so looking at these pictures, I got me some trapezoids. I can tell because each of these shapes has one set of parallel lines. It's kind of hard to see over here on picture number 2, but there's actually, it's hard to see on mine, that we got some markings that we got an isosceles trapezoid. So it says find the measures of the missing angle. So first thing I'm looking over here at this first picture, and because these two marks are here, I know that my two base angles are congruent. So 42 degrees for angle D. And then the other thing I have going on is I know that I have parallel lines. So at the end of the day, you have parallel lines that go like this. We also know that if we look at these two angles, that they are supplementary. So if I want to find the measure of angle B, it's going to equal the measure of angle C because the trapezoid is isosceles and it's supplementary to those other base angles. So I can take 180 minus 42 and I get 138 degrees. All right, looking at my next picture, trapezoid's on its side, so please note that the parallel sides are on the left and the right. But I have an angle that's 100, that's a base angle, so this angle down here is the other base angle. And I also know the two angles down here, they are congruent, but they are also supplementary to 100. So angles that are supplementary add up to 180, and they've given us some pretty quick math for this. All right, moving on. Let's talk about the midsegment of a trapezoid. We have talked about the midsegment of a triangle, and it connects the midpoints of the sides. Same thing with the trapezoid. It is going to connect the midsegments of the legs. So the one word that kind of sets this definition apart is connecting the midpoints of the legs and not the parallel sides. And the formula for the midsegment is half of base 1 plus base 2. So, got you another meme. I just was feeling funny when I made this little slideshow. Haha, okay, moving on. So make sure you copy down the formula for the midsegment. Instead of being half of the third side, you have to add your bases together and then take half of your bases. So looking at example 3. In the diagram, segment MN is the midsegment of trapezoid PQRS, and we are going to find MN. So our midsegment formula says that our midsegment MN is going to equal half of base 1, which is PQ, plus base 2 in this picture, which is SR. So the length of PQ is 13.5. The length of SR is 18.9. I do not have a calculator, so 13.5. Hoping this is 32.4. All right, half of 32.4, half of 32 is 16, half of 0.4 is 2, and because we started this picture with units, we have to attach units to our answer. All right, beautiful, not so bad. All right, moving on to example 4. We have trapezoid JKLM. J and M are right angles. So if I draw a trapezoid and I have 2 right angles. So in this trapezoid, this side is going to be parallel to this side. And it says J and M are my right angles. And since my trapezoid is JKLM, K and L have to go there and there. And it says that JK is 9 centimeters. We have a mid-segment NP, so here's my mid-segment, and they called the mid-segment NP, and they tell us the mid-segment is 12 centimeters. And it says to sketch the trapezoid and find its mid-segment, or find ML, and explain your reasoning. So we could do this a lot of different ways. I taught you guys the process of ME. So if we think about what the distance is from 9 to 12, to go from 9 to 12, I added 3. So if I want to continue the pattern, I could add 3 and I could get 15 centimeters. I also know that the mid-segment in P is going to be half the sum of the bases. And because I know the length of NP, I can substitute in 12. And if I want to continue on with this, 12 times 2 is 24 equals 9 plus ML. Move my 9 over, and ML is going to equal 15, and make sure you attach the units. All right, so either way you think about that, both of those methods are mathematically accurate for the mid-segment. Okay, let's go fly a kite. What is a kite? It's exactly what you think it looks like when you picture a traditional kite. It is a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. So we might have a pair of congruent sides here, and we might have a pair of congruent sides here, but the blue and the green are not going to be congruent. So properties of kites. Diagonals are perpendicular, so right here in the center of my kite, I have 4 right angles. And exactly 1 pair of opposite angles are congruent. So in a kite, we have 1 pair of opposite angles that are congruent, but the other pair can absolutely not be congruent. So let's apply those properties of kites. So looking at the particular picture of quadrilateral ABCD, we have a kite because they told us in the instructions. So we have to remember that in our properties of kites, they said that we have 1 pair of angles that are congruent. So I know that C and A have to have the same measure. So I could actually set up a problem that says x plus 80 plus 50. This is a quadrilateral. I know that a quadrilateral is formed by 2 triangles, so the sum of all those angles is 360. I can do a little bit of cleaning up on that algebra, and I can actually find the value of x. And if I do that, the angle C and angle A are each 115 degrees. So that equals the measure of angle C, which is also the measure of angle A. Got my little M's. There you go. All right. So example B on number 5. 5B, quadrilateral DEFG is a kite. What are the measures of angle 1, 2, and 3? So, and a very cool thing, we learned that the diagonals of a kite are perpendicular. So that makes angle 1 very easy. The measure of angle 1 is 90 degrees because we know that perpendicular lines form right angles. All right, so then I know that this angle is 52 degrees. So if angle 1 is 90 degrees, then angle 1 plus 2 have to add up to 90. So the measure of angle 2 is going to be 90 minus 52. which is 90 minus 50 is 40, which is 38 degrees. All right, so that means this angle is 38. And it also means that this angle here is 38, which means that the measure of angle 3 equals 52 degrees. All right, excellent. So, let's talk about that for a cool second. I know that this side and this side are congruent. I know that this side and this side are congruent. I know this side and this side are congruent. So by side, angle, side, the big triangle on the left and the big triangle on the right are congruent, and that makes these two angles at the top by corresponding parts of congruent triangles are congruent. I know your favorite part about proofs. And then those two angles at the bottom are also going to be congruent. That's not true about these angles here. Okay, so that's not an angle bisector because the triangle on top is obviously not congruent to the big triangle on the bottom of the kite. All right. Last but not least, what is the most specific name for each of the following quadrilaterals? So I want you to think about all the properties we've learned, properties of rhombuses and rectangles and kites and trapezoids and parallelograms, and I want you to see what you can come up with for the following problem, and we will pick up with example 6 when you arrive in class tomorrow. Have a great evening, afternoon, day, and I will see your bright, shiny faces in the morning. Bye.